Currently, Parks Canada is removing T-bars at the end of the summer season due to the winter freezing them into the ground, making them very difficult to remove by hand. As of right now, they've been using their hands to manually pull the T-bar up or use a shovel to dig around and then wiggle it free. This causes a lot of stress on the worker as they're pulling up hundreds at a time, and it makes it very difficult for them to pull up just one. So, we've designed a solution that quickly and efficiently removes the T-bars by just using the worker's upper body strength, which reduces the stress on the body and just makes it simpler for the worker to pull up hundreds at a time.
So this is our T-bar puller design. We use the lever mechanism to make the tool. The reason is that the foot point can help us to reduce the forces we apply to the T-bar significantly lower. Basically, we have four components here. We have the stand with the stand here. We have the handle with the red color, and the main component is the T-clamp. The T-clamp is connected to the handle by using a strap. So when you put the T-clamp into the T-bar and move the handle down, it will lock on the T-bar, and when the handle becomes up high, it will loosen the T-bar. So we can repeat the mechanism until we remove the T-bar off the sand.
As you can see in the video, we dip the T-bar 3 feet into the sand. When we apply the forces into the handle, the T-clamp will lock into the T-bar, and when the handle up high, the T-clamp will loosen and get back to the final position.
So one of the biggest advantages of our design compared to the original solutions, which requires using hands and shovels to dig up the T-bar, is that our solutions has more efficiency and take less time to actually pull up the T-bar. So here's the video of us setting up the T-bar in less than 30 seconds. Here's the video of us pulling out a rusty T-bar that's been left in the ground for many seasons. So here our solution, pulling a T-bar almost completely buried in the ground.
For the final tool, replace all the material with aluminium to create a lightweight solution. As a result, our solution would be roughly the same weight as a shovel. There are 4 parts involved in the tool: stand, lever, strap, and a T-clamp. For the stand, it consists of a pointed edge to allow the base to bury into the sand easier. There is a stepping plate that uses the worker body weight to bury the tool deeply. And for the lever, an aluminium bar with a cylinder welded below to attach a pin to the stand. And for the strap, it is connected to the end of the lever and the T-clamp to connect the two holes together. And lastly, T-clamp, made up of a lightweight aluminium, and it has a T-shaped hole in the center to slide on the T-bar and lock when force is applied.
To conclude this presentation, we believe that this tool would reduce body strain and increase the efficiency and happiness of Parks Canada employees. We look forward to possibly working with each other to implement our design into the field.